So this video is going to be about scientific notation and how to write it. If you have a number that's really big that you want to change into scientific notation, or take something that's in scientific notation and write it down in its full form. So the first things we're going to talk about is the rules for something to be scientific notation. So the first thing, if you see something that's in scientific notation, it's going to look something like 5.2 times 10 to the third. Alright, so let's pick this apart. This first number right here, that needs to be greater than or equal to 1, and it needs to be less than 10. So it should be a one-digit number with a decimal after it, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, decimal point, and then the rest of the number. It shouldn't be more than 2 digits long before the decimal place. Then we're going to multiply it, right? And it has to be this kind. It must be this multiplication sign. We can't use the dot. We can't use the little star thing. You have to do an X. I don't know why that's the rule. It's just the way science wants to do it, I guess. And so then this very last number is going to be 10 to a power. Right? Now, when you first look at this, I don't know, I just think it looked, I remember when I started, it just kind of looked like a jumble of numbers to me. I didn't really know what it meant. But it's actually super easy once you get used to it. So if we wrote this out again, 5.2 times 10 to the power of 3. So what does this really mean? 10 to the power of 3. That means 10 times 10 times 10, right? So 5.2 times 10 times 10 times 10. So that's starting to look more like a problem I can deal with. Now, if you already know, you can just say, oh, all these 10s equal 1,000. So what's 5.2 times 1,000? But let's say that you don't know that, right? So what's 5.2 times 10? Let's start with that. 5.2 times 10, we know that if we're multiplying by 10, we just move the decimal place over 1, right? So if we move the decimal place over 1, we'd end up with 52. Times 10, got to bring these other 10s down, times 10, got to bring that one down. Okay, so now let's do the next one. So 52 times 10, that's pretty easy, right? So we need to move the decimal place over again. So that's going to be 520. Because 52, add a 0, 520. And then we'll bring this very last 10 that we haven't used down, right? Because we used that one. Now what is 520 times 10? We add a 0 to the end. That's going to be 5,200. Okay, so if you look at this, we added 1, 2, 3 zeros to this. We didn't add 3 zeros. We took this decimal place and we moved it. It started here. What's the difference between this and 5.2? The decimal place started here and we moved it over 1, 2, 3 places to here, right? So if we moved the decimal point over 3 places, that's the number that's right there, isn't it? So the easier way to do it, if you don't have time or if it's such a big number you can't do all this work, and see that 5, 2, you started with the decimal place here and you're moving it over 1, 2, 3 places, putting it right there, and then adding in your zeros. And this is the way it's going to work for any problem that is a scientific notation problem. Let's say that you had 1.625 times 10 to... So if you took this problem, and you know your rule about this 5 up here, that you're going to take that decimal point and move it 5 places over, 1625, your decimal point started here, 1, 2, 3, 4, 5, you're going to put it right there, add your zeros, and you know that this is the number, right? 162,500. That is what 1.625 times 10 to the 5th is. We can do it with a couple more. We could do, let's try 7.6 times 10 to the 10th. Right, this one, that's that 10, that's a pretty big number. So 7.6, and our decimal point started here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Add your decimal point there. Put your zeros in and all those empty spaces that you skipped. And this is a time where it's really useful if you're using graph paper, because then you can use those empty squares to tell how many zeros you have, and every time you jump over a spot, you just make it the same size as one of the squares. Because sometimes if you're using like a lined piece of paper like this, and maybe you had 7, 6, and you're trying to count 10, and then you have to go back in and add your... If you're using graph paper, that makes it a lot easier. You can just make each of your decimal point jumps the same size as one of the squares on the paper. So anyway, so this is your answer of 7.6 times 10 to the 10th. Now you can also do this whole process backwards, right? So let's say that we had 5,640. And we're trying to turn that into scientific notation, right? So we want to turn that into scientific notation. We know the first number has to be between 1 and, well, it has to be more than or equal to 1 and less than 10. So the decimal point has to be after your 5, right? So 5.640. We know this is what we're trying to get to, times 10 to a power. We don't know what that power is going to be yet. Now, if we look at our 5,640, we know that right now the decimal point is right there. And we're trying to make it right here where the comma is. So we can count our spaces. 1, 2, 3, right? 3. So if we put a 3 up here, then we know that that decimal point moved over 3 places, right? So you just have to do the same thing but backwards. Because if we had 5.640 times 10 to the 3rd, we would do what we did before and say, oh, the decimal's here, 1, 2, 3, now the decimal point's there. So you just have to do the problem backwards if you want to get from a number to scientific notation. Another example would be, let's do 6 million. How are we going to turn that into scientific notation? Well, we know the first number has to be between 1 and 10. So we have the 6 here. So we'll use 6 times 10. We don't know what the power is yet. But if we know the decimal point's going to end up here, let's count how far it is to get from where the decimal point is to where it needs to be. 1, 2, 3, 4, 5, 6. 6 places. So 6 times 10 to the 6th gives you 6 million. You can also have scientific notation where these exponents instead of being positive or negative. And we'll talk about that in the next video.